Hello. So let's revisit the post-processing now for this case. So these are generic comments that are valid for 2D, 3D doesn't matter. But as you recall, the previous two cases that we run, all this post-processing now, doing this profile, the stuff like this, exactly the same way we did it in these cases. You can do it for this case, okay? Nothing changed, okay? It is exactly the same post-processing. You compute Y plus in the same way. You plot these profiles. Okay, nothing changed. So the thing is that you set a line, sampling shear stress, and then normal to that location. Okay, so in theory, in this case, you can do the same. For instance, remember, it's not a good idea. These plots is you have separation. This you will have a different curve. Okay, at least in the low region. So you can do it where you know that the flow it is attached. So for instance, you can do it here in this location, sample shear stress, normal to the wall, and start to plot all the profiles. You can also do it here and you will see the differences we have seen in the theory. Later we're going to revisit that one, but the profiles deviate a little bit from that theoretical because we are not in ideal conditions. Okay, so all these plots that you see here, okay, can be reproduced exactly in the same way. You can compute wall shear stresses, all those quantities. Okay, here you have in functions Y plus, you have all the turbulent quantities, velocity profiles. Okay, so there is no limitation. One thing important that as we are running on a steady, it is recommended that the wall shear stresses and all those quantities, you use the average quantities, okay? Use the mean quantities. If you use instantaneous quantities, you will get different values if you sample in different times. So that's why it is important to sample your time statistics. So when you go in post-processing, you will see that all that information, okay, it is available. Again, just to remind you, you go here, you have on a steady statistic and see that you have all these fields here. So here you have the basic field. You don't have turbulent kinetic energy, that is tough because we didn't say to sample, but you can also say to sample that. So see that you have on a steady statistic of the flow, but also wall quantities. See that you have pressure coefficient, wall shear stresses, and mean skin friction coefficient. So please use mean values, okay? Do not use instantaneous values. If you want to compute some other quantities, the statistics, see here that you have this action here, sampling actions, okay? Well, you can see sample that, but also you can say data file quantities, and here you can choose what you want to sample for the statistic, okay? So you just pick up new quantities and you will sample that here, okay? So if you have more quantities or additional quantities, just select that and you can sample that. So for instance, you want to sample now turbulent kinetic energy, select here, and this will become another quantity, okay, that you will sample. Okay, so these are your standard quantities that you will sample, and then you keep adding here new quantities. Turbulent intensity, okay, you will add it to your sampling the sampling quantities. So the final part, so remember the points here, okay, you create lines and everything the same way, you plot in surfaces here, you can also compose scenes. So let me show you one here that, for instance, I have contour 3, this one, and I want to put that one, so see that you have like this, and then I can add the velocity vectors as well. So you can compose all these lines, and for instance, I can do, let me do, for instance, pass lines. Okay, let me do this one. So I want to release pass lines from the cylinder surface. Okay, so you select this one, pass the skid, put 2. Okay, not enough. Okay, so here it's not, you need to put it in a surface that is not precisely, you know, in the wall, but you get the idea. So let me, for instance, probably here will be, if I choose this, okay, no, it's all line will be, okay, sorry, that one should be, all lines will stick to the plane, so this should be this one. Okay, so yeah, so this one will take, probably will, okay, see that now this, okay, let me skip here. So basically, okay, have it here and releasing from the plane, and then this is sticking to the walls. Okay, so see that now you can get this one and these strings lines and put by velocity there, and there, see that you have those lines there. So the post-processing, as you can see, can be very complicated. So here, if you want to do the animations, the solution using these fields like this, you cannot do it because we didn't save all the Fluent files. However, we save all those Fluent files. So let me go back, and I had that key here, was working here. We save all the Fluent here in the Ensight. So if you go to the bottom, you will see that you have the Ensight here. Okay, so you save everything. So later, the final video, you will have access here. You will see the Ensight, and here you have all the data. I'm going to show you how to do that post-processing. But there is nothing particular, okay, for the unsteady. The additional thing that I want to show you, that remember that you set up this animation here, okay, in calculation activity. So now you can also post-process that animation here and playback. So as you press here, we already did it, but just to show you again, play, you will see the animation, okay? So basically what you are going to see is precisely what you set here, okay? You are taking this information for control 1, so it's precisely what you are putting here, is what you are seeing here. And at the time of the simulation, now as I change it now, you will still see this one, but this is at the time of the simulation. And so I mentioned, you can save the video here, and then just write, and then it will save the video. Okay, so see that here, it started to save the video. I think it will save in AVI format. Okay, so we should have it here. So yeah, so what it do is save these PPM files, and from the PPM files, then it will put all those files in a movie format. So let's wait to see when it finishes the video. So it's a little bit time consuming, by the way, the video, because it's saving all these frames. So here's, you have 10,000 frames. So it will convert everything and then need to stick all those frames into a video. So sometimes it might be time consuming. So let's wait to see what happens here. Okay, so I think in my case, okay, it's done. Okay, it has the frame. So if I go back here, see that you have here the movie, and well, you double click, it's MPEG format. So you need to use the right program. So in this case, should be VLC, and where I don't see the option open with here. Okay, VLC. So here you have the movie, okay? So as you see, well, you have it here, the scales are dynamic. It's not the nicer format as you see, but you can save it that directly in Fluent. And Ensight, I will show you a way that you can have nicer animations that like the ones that you see, you know, in this presentation. The only thing is that you need to save that data, okay? So that saving that in Ensight format, there are many formats. The one I recommend you is Ensight, but can add an extra overhead. So that's all that I want to address regarding this. Well, finally, also remember in reports here, you can compute all your integral, fluxes, and everything, okay? So that's all. Then next video, we're going to move to this option here. We're going to do the analysis of the time series. So if you didn't run the simulation here, you can download the time series here. I run up to 100. Okay, so that's all. Thank you. See you next video. Bye.